Hello everyone. So today we're going to talk about a very popular dynamic problem, which is longest increasing subsequence, also known as LIS. So what is longest increasing subsequence? The proper definition is the longest increasing subsequence problem is to find a subsequence of a given sequence in which the subsequences elements are in sorted order, lowest to highest, and in which the subsequences is as long as possible. So there are two things to be noted down, that they need to be in sorted order and also they need to be lowest to highest. Actually, when we really hear the word longest increasing subsequence, we really get the essence of what this problem is really about. It needs to be the longest and also it needs to be the increasing. So the usual type is it need to go like some one like 1a 1 2 1 3 says a 1n. It goes like something like this. So let's take an example: 6 2 5 3 9 12 8 11 13s. So in order to attain a longest increasing subsequence, there are points to remember, that the subsequences needs to be increasing, also it needs to be the longest one. So let's dive a little bit more. Okay, so the given sequence we can see is 6 2 5 3 9 10 8 11 13s. From this sequence, we are taking two sequences. One is 2 5 9. We can see that it is following the order. Also, it is increasing. And about the next one is 9 10 11 13. It is also increasing. So both, we can say that both of them are increasing subsequences. But we take the second sequences. And why is that? Because we need to find the longest one. Since this one is the longest one and the other one is not the longest one, we are going to take the second one. And there's another sequence is given, which is 6 2 5 3 9. We won't be taking this one. And why is that? We won't be taking this one because it might be a sequence, but it is not an increasing subsequence, because as we can see the order, we can see that before 2 it comes 6, after 6 there's 2, so we can say that this is really not increasing, so we are not going to take this. Also, there happens to be a naive approach for this longest increasing subsequence, and for that we're going to do is, let's take an array of length I, Li. Let L be the length of a longest increasing subsequence ending at position I. Let me elaborate a little bit to make it more easier sound. So on length array I position, there will be the length of the longest increasing subsequence ending at point I. So we are going to using a dummy a equal to 1 equal to minimum. Also we'll be taking L on the array I, we're going to put a 0 equal to 0. So now let's see the real simulation. So the L5 indicates that if we check 5 elements of the array, within the 5 element, where would be the longest increasing subsequence? Now for any of the next number, we could do is, if the previous number is small, then with the while lasting one, if 1 is added, we find the longest increasing subsequence for the next one. Okay, now we are going to dive into the simulation. So here we can see that we have different parts, like one is index, input, length, and previous. I'm going to explain each of this step with the following time. So now let's see that there's index 0. So for that, input is 0. Also the length is 0. And we're putting the previous as -1 since there's like no previous right now. So on index 1, we see that the input array is 6. So this is index 1. Now if my length is 1, then for that the longest increasing subsequence would be 1. Since there's just 6, just one element, just to one increasing, just one element, and for this element we have checked this element is just the longest, so we are going to put 1 as our length. If we go further and take the index 2, for that the previous element is 6, and we can see that 2 is smaller than 6. So we are going to take the smallest one. Smallest input here is 0. For that the length is just 1. So here is what the interesting part really comes, that in index 3 the input is 5 and 5 is larger than the number 2. So we have explained that how we are gonna add 1 when we find the number that has smaller one, because in order to find the increasing one we can just add 1. So for 5 we can see that it has a smaller number which is 2. So 5 is bigger, thus by adding 5 with the result of 2's position we get a increasing subsequence. So with the combination of 2 and getting the length 2. Okay, so now let's move the index 4. For the index 4 what we're gonna do is we will be okay, so this goes on. Now let's see the index number 5. On index number 5 we can see that our input is 9, and as for 9 we can see that it has some smaller number which is 3, 5, 2 and also 6, but we are not going to take none of them. We're going to take that the value which is already the maximum. So we are going to take 2 which is already the maximum number, so we are going to add 1 with that in order to find the increasing length of 9. So okay, so we got the length of index 5 as 3. Now the next number is 10 of it, and it belongs to index number 6. So number 10 has the smallest number, closest number to number 10 is number 9, and number 9 already has the biggest length. So we're going to take this number 9 and the length of it, we're just going to add 1 with it. So we get, because we can see that the it gets its length from number 2, and the input 3 has the index 4, thus we are putting 4, and that's how we can keep the track that where these indexes are really coming. This prep will really help us to get number sequence, thus we are also keeping it here, and this method runs in n squared time. And now what about the time complexity? By using the C programming, okay, I'm sorry, it will be by using dynamic programming with the binary search. It could be done by n log n. So the longest increasing subsequence in an array of integers and its time complexity is n log n.